Hi, welcome back to another episode of Mr. Ray's Geometry Podcast. Today we're going to continue looking at parallel line proofs. What we have on the board is a relatively straightforward parallel line proof. It also is going to involve isosceles triangles, so there's a lot going on here. Let's take a look and see what we have. So in this picture we're told that BA is congruent to BC. We're also told that angle BDE is congruent to BCA. They're asking us to prove that a pair of lines are parallel. In this case, DE parallel to AC. So let's start like we would any other proof. We're going to mark up our picture with the information that we have. BA congruent to BC. And they're also telling us that BDE, this angle here, is congruent to BCA, this angle down here. So when you mark up that picture, there should be something that's just popping off the page at you. There's a shape there that you're always wanting to look for when you're doing proof. You're looking for, do you see it? An isosceles triangle here. If AB and BC are congruent, this large triangle, ABC, is isosceles. And that's always useful in a proof. Whenever you have an isosceles triangle, you want to look for them because that tells you something about angles. And in this proof, that's going to be the key. So what does it tell us specifically? Well, if this triangle is isosceles, its base angles are congruent. What are the base angles? That would be A and C. So we know now that angle C and angle A are congruent angles. Well, look what we have. BDE is congruent to BCA, which is angle C. And now we know that angle C and A are also congruent. So it should be just a small leap for you to say that this angle here and this angle here have to be congruent as well. Well, that's a good thing, because those are a special type of angle. Remember what we're trying to prove. DE parallel to AC. This line parallel to this line. There's only 4 ways to prove lines are parallel. You're going to look for alternate interior angles that are congruent. You're going to look for alternate exterior angles that are congruent. If you can find corresponding angles that are congruent, or a pair of supplementary same-side angles. Well, if you've been watching my other videos, you know that we're usually looking for alternate interior and corresponding angles first. In this picture, you should see a pair of one of those two. These angles here are corresponding angles. If you don't see it, try extending the lines a little bit. If we take DE and make it just a little bit longer, and CA and make it just a little bit longer, and I'll even extend this transversal. Now, hopefully you're seeing, if you didn't already, that these are corresponding angles. And if they're congruent, that's going to make those lines parallel, right? So that's what we have to say in our proof. So, we have our givens. The first thing I'm going to want to say is that these base angles are in fact congruent angles. Now you have a choice here. You can go right to angle BAC, congruent to angle BCA. Now this is the way I would do it because I like to save as many steps as possible. This is sort of the shortcut. If you're going to say that BAC is congruent to BCA, what's the reason? Well, we have this theorem that says in a triangle, right? In a triangle, the angles that are opposite congruent sides are congruent. In a triangle, angles opposite congruent sides are congruent. That's going to let you go right to BAC congruent to BCA. Now, there's another way to do it. It takes 2 steps, but it's perfectly fine. You could say, well, wait a minute. Mr. Ray, look, if AB is congruent to BC, that means ABC is an isosceles triangle, which is true because it has 2 congruent sides. And then you can tell me these angles are congruent because the base angles of an isosceles triangle are congruent. It's completely up to you. Either way is just as good as the other. I like to do it this way just to save the step. So once we have BAC congruent to BCA, there should be something else jumping off the page at you right now. We kind of saw it already when we labeled our picture, right? If these angles are congruent and these angles are congruent, then it's obvious that these two are congruent. How do we put that in our proof? Well, if you look at these 2 lines, you should see a substitution. If BDE is congruent to BCA, and BAC is congruent to BCA, then it should be easy for you to see that angle BDE is congruent to angle BAC. All I'm doing is replacing this BCA with BAC here. So that's a substitution on steps 1 and 2. And that's really good, because what do I have now? I have angle A congruent to angle BDE, and those are corresponding angles, right? Here, congruent to here. So now I can say that these lines are parallel. I'm going to be able to say DE parallel to AC. Now think about your reason. It's a long one, but just think about what you're trying to say and it'll make sense. You have these two lines, right? You've got this transversal going across the lines. You've now discovered that these corresponding angles are congruent. So the lines have to be parallel. That's all you're going to say. Two lines cut by a transversal with congruent corresponding angles are parallel. Two lines cut by a transversal with congruent corresponding angles are parallel lines. And that's it. There's a parallel line proof using corresponding angles to prove two lines are congruent. We use the isosceles triangle in there as well. Angles opposite congruent sides. And it's done in 4 steps. So I hope this helped. Please let me know if you have any questions or proofs that you'd like to see me do in particular. And as always, thanks for watching. Have a great day.